Hi, welcome to the EEVblog, an electronics engineering video blog of interest to anyone involved in electronics design. I'm your host, Dave Jones.
Good morning, everybody.
Morning.
Morning. Those of you who aren't morning people, morning, everybody. This is A19C, Super Nuts with Free Software. My name is DJ Delorie. I'm a senior engineer at Red Hat, work in the Global Engineering Services group. We do primarily embedded systems, cross developers, etc. I've been working with the GNU tools since 1998. I've also worked with the GNU tools on DJ GPP since 1989. And my first experience with the Renesas MCUs was in 1992 with the H8300. I'm also one of the co-maintainers of some of the free layout software that I'll be talking about later, and author of the R8C, M16C, M32C, and R32C flash programming guide for people who wish to do their own these chips. So hopefully by now you've seen this chart talking about all of the wide range of products Renesas offers. The things that I'll be talking about today cover pretty much most of these, since we're talking more about the environment in which you use these products, not the products themselves. But we're going to focus more on the microcontrollers and microprocessors area. This is the lineup of the Renesas microprocessors. And although I have my favorites, you guys all do too, we're going to cover pretty much all of them. The techniques that we'll cover today cover pretty much all of the processors you see there. I think we don't support the 720 to the 780K, but that's about it. Now, long presentation. So what's the innovation here? And I had some really pretty pictures to bring up. So we're going to talk about some of the people who have used free software or the concepts behind free software to innovate with their products. And then we'll talk about how you can use those same concepts to innovate with your products. Companies like Red Hat, IBM, id Software with their Quake game, Android operating system, Linux kernel itself, and even the companies like Utopia, who did one of the first Linux-based smartphones, and even Apple uses free software to produce their products, despite the fact that everybody perceives them as a closed company. They do take advantage of the free software philosophy to innovate with their products. So what does this mean? It means to me new business models, mean new opportunities for you to interact with your customers and your suppliers. And my position is that free software enables mass uptake of your products and freedom to innovate. Using free software in your business gives you control and flexibility. And using free software in your products gives you customers control and flexibility. That allows them to do more. It allows them to do things the way they want. And not everybody agrees with this position. So the agenda today, we have a few things to cover. We're going to cover the business end of using free software. And what I mean is how to use free software for your daily business needs. Email, web browsing, your business back-end databases, all that stuff. I'm going to talk a bit about using free software to design electronics. Hopefully by now you've all seen a nice pretty pink sheet of paper with a little circuit board in your goodie pack. This board was designed entirely with free software. And the embedded development tools for free software will be the next topic. And again, all the software that I write for these boards is all free software. And then finally, we'll spend some time at the end to talk about the philosophy behind free software, how you can apply it, what it means, how to integrate it into your business. And throughout, we'll be stopping at the end of each section for questions and answers. So let's cover some examples of innovation which came about because of the free software philosophy. The original IBM PC, most people don't think of it as being free software. It's kind of before that, but one of the key things they did was they included with every PC the BIOS listings. specifications for the hardware so that you could add to their platform. You could put your own things in there. You could do things with it that they didn't anticipate. And because of that, people have some arguments of whether, from a technical point of view, it was the best platform. It certainly became the most popular platform. You can see where that went. The LAMP stack, some of you might have heard about, Linux, Apache, MySQL, Python, is becoming very popular in the business world as a back end for businesses, and it's based entirely out of free software. So the businesses who use this can apply it the way they want. Quake 3. Most people don't think of video games when they think of free software. But when Quake 3 came out, id Software specifically licensed their games to allow, in fact, encourage people to add levels, to use what they had produced, to extend it, to do more things with it. And because of that, their product was relevant and fresh and usable for much longer than you would have expected. The GNU toolchain you've all heard about these last few days, talking about GNU Rx. The concept here is that with many contributors and many users, a product can become ubiquitous. Everybody knows what the GNU toolchain is. Everybody uses the GNU toolchain. Everybody supports it. And they got that through the free software philosophy. And finally, you've probably seen many of the smartphones today are starting to use the free software offerings in order to get their product to market faster and concentrate on the pieces that are specific to them and let other people worry about the parts that are common. So what does free software mean? A lot of people talk about free software, not a lot of people actually know specifically what it means. And they think, well, it's not free because I can't do everything I want to do with it. Or it's not free because they charge me for it. It's not entirely about what the user wants. Free software is about what the software wants. The software wants to be free. And by free, I mean there are certain freedoms that the software grants to the users. And free software is about making sure that those freedoms are maintained. For starters, free software means that you have the freedom to run the program for any purpose. You can't write a piece of software and say, well, you can only use it the way I tell you. You can only use it in these countries. You can only use it for these purposes. You can't compete with us with our own software. You have the freedom to run the software for any purpose you want. You have the freedom to study how the program works and change it to make it do what you want. So if the software doesn't fit into your needs, you can make it fit into your needs. You have the freedom to redistribute copies to help your neighbor. Now, in the free software world, they talk about neighbors, but who are your neighbors in your business? They're your customers, your suppliers, your partners. Those are your neighbors. The ability to share your software, the tools you use with them, allows you to work together more efficiently. And finally, the freedom to distribute copies of your modified versions to others. So if you get something, you have not only the option to enhance it to fit with your business practices, but then you can share it with your partners so that they have the same business practices, the same extensions. So let's talk about how you would use free software for your business. I mean your daily business needs. Desktop. There are a couple of different standard desktop platforms available today. The most popular ones being the GNOME and KDE desktops, which you find in most of today's Linux-based distributions. They include such things as the Firefox web browser, mail readers, news readers, PDF readers, all of the usual things that you need as part of your daily business life. I want to check my email. I need to go online. I need to download some specs so I can read about something. These are all standard in most of the Linux-based distribution desktops. There's also a full Office suite included. OpenOffice is basically all of the things you need for your standard Office needs. Word processor, spreadsheet, database, presentations. In fact, this presentation was developed using OpenOffice, not PowerPoint. Well, I did double check it before I sent it. And you get some extras in here that you normally wouldn't get in an Office package. For example, OpenOffice can export to web pages and PDFs by default. It always has. It's It's never been an extra thing you had to buy separately. And servers. Many businesses use servers for databases, for their mail, for their web, DNS, DHCP, NFS, Samba, routers, firewall, FTP, IRC. Most of the internet runs on free software. So anytime you go out and visit a website, there's a really good chance you're using free software too. And there are other packages as well that other companies have used as part of their grouping things together. So any questions so far on this stuff? This actually goes kind of quick, but people ask a lot of questions.
What's the link between OpenOffice and Java? Because I think when I do my Java install these days, it asks me about when I install OpenOffice. Is there some link there between?
The link between Java and OpenOffice is they're both produced by the same group, which would be Sun Microsystems, now part of Oracle. So that's kind of a product tie-in thing. There's no technical reason why, but it's part of the whole package deal from Sun Microsystems. Does anybody use any of these software yet? Oh, excellent. Preaching to the choir. How many people use a Linux-based distribution by default?
Some people.
Well, you'll convince the rest of you. Moving on. EDA Tools. These aren't quite as well known as the office automation tools because there are fewer engineers in the world than there are, well, everybody else. There's a couple of different EDA suites that are free software. I use the G2PCB suite because as I'm one of the developers and it does what I want. The G2 suite includes the usual things: schematic capture, board layout, simulation, and a few not quite so ordinary things: scripting, the ability to integrate with makefiles in your backend processes, databases, and to extend into other unusual fields. Bill of materials, Gerber exportation, documentation generation. And these are available on all of the common platforms: Linux, Unix, Macintosh, Windows. In fact, it supports Mac better than Windows because Macintosh is based on a Unix free software environment as well. And all of the file formats that they use are all also freely documented. They're open formats. They're easy to use. They're text files. You can run them through any program you want to, modify them in case the tools don't do what you want. Write your own tools. And the other common suite that people use is the KiCad suite, which basically does the same thing. They have schematic capture, they've got the layout programs, they've got all of the usual things, and they again support all of the major platforms. And the power of the open source EDA talks, it really shows up. When your design flow needs to do something different, something unique. If you buy a commercial package that has everything grouped together, you're basically stuck doing things the way they want to do, because everything is designed to work their way. But with the open source tools, if you want to do something different, if you have some unusual way of managing your EDA flow, then you can do that. The beginner might only use common programs in the expected ways. When you start getting into larger projects and more mature departments with large databases of products, and they have their own flows and their own internal part numbers and everything like that, these tools can be integrated into that process rather than trying to integrate your process into the tools. So it's a lot easier to streamline your EDA environment using free software. In fact, I know one guy who has this huge system of makefiles and scripts, back-end databases in order to take all of his archives of old schematics and migrate them into new products so that you can reuse old pieces of old projects without having to go and re-edit all of the schematics. It's all done with a giant process flow that feeds everything through. And for some examples of these custom flows, when I do my own circuit boards, after I'm done generating the circuit board, I have a series of scripts that I run that modify all of my layouts. in order to compensate for the process that I use to generate circuit boards. It might adjust the size of via pads on different layers depending upon what's connected to it and whether or not I'm going to be using my 4-layer process or my 2-layer process in order to cope with the process issues that I have. It also takes that same circuit board and extracts some of the pieces out of it in order to generate new circuit boards that I use for doing things like paste layout and renderings and assembly drawings. And some of the experiments that people are doing with the software, which you don't normally see with proprietary software, are also interesting. There are some versions of our tools that have been modified to use 3D renderings of your circuit board, so you can rotate it around and see the stack-ups and represent the layers, how the layers interact with each other in 3D view. Or they use the GPUs in cards to render all of the layers translucently, so that you can see through what you're doing. These are all experiments that people are doing outside of the core development, and you normally wouldn't be able to do that with proprietary software. And of course, all of the tools use standard formats for their outputs and for interactions with other vendors. I often get people asking me, well, your free software, what PCB fabs support your output? Well, they all support my output because I use standards. We do not use proprietary formats. We use open formats. I can send my output to anybody. And we have, of course, the usual tools for reviewing the output files and checking all of your work and making sure that everything is the way you expect it before you send it out. And we include a number of simulators as well that are all open source. We have digital simulators that support Verilog. We have the analog spice-based simulators. And they're working on a next generation simulator that's a mixed mode that can support both digital and analog simulations together in the same package, including all of the previews and the charting and everything for it. Let's see what these look like. These are some examples of schematic capture and circuit layout, and hopefully by now you've all played with your little circuit board. The schematics and the layout that you see on the board are that board. The applications resemble most of the applications you're probably familiar with. They use the same look and feel as most Windows-based applications. They're fairly intuitive to learn. But if you want to do more with them, if you need a more powered interface, they have those as well. And you can even modify the interface yourself to use scripting. You can hook scripting up to menu items. You can tie them with other bits of your process that weren't originally included. And here's some screenshots of the KiCad suite. As you can see, it's basically the same, all the same user interface stuff. Slightly different functionality, a little more integrated, depending upon whether you prefer an all-in-one solution or a more expandable building block type solution. And here's some examples of the post-processing tools. Yes?
I'm going to announce that anybody who tried KiCad last year may have been disappointed that it didn't have undo. Now it has undo. So if you want to go back and look at it.
And with all of these packages, development continues. And we have people who say, I have your latest release and it's got these bugs. And it's like, well, if you have our latest release, you don't have our latest release. Because we're still working on it. If you want to get it right out of our source control system, we fixed that bug and many other bugs and added some other features.
I've heard rumors for the experience of these tools on Linux versus Windows. Is the experience better when using Linux?
The question is what's the experience between Windows and Linux for these tools? And indeed, the developers use Linux, so the tools tend to run better under Linux. But they work pretty much the same under Windows. There's a few issues with some of the more esoteric features. For example, the layout editor can generate footprints on the fly using a scripting language in order to import them from a dynamically generated definition of your element. Well, in Windows, the scripting tools aren't there. So unless you've gone and installed the extra packages and gotten them working, those extra features are going to be hard-pressed to function. But if from a point-to-click point of view, they're pretty much identical. And the KiCad folks try very hard to make sure that their stuff works exactly the same on everything. Now, if you want to compare Linux to Macintosh, different answer. The Macintosh stuff works flawlessly. because they are built upon a free software basis as well, and they have all of the essentials. And it's, again, another case where you want to try the absolute latest stuff because we're continually working on improving the Windows experience.
You pull the scripting tools from Cygwin then? You pull the scripting tools for Windows from Cygwin.
Do we pull the scripting tools from Cygwin? There is a Cygwin build of these tools. It's called the Portable Jita. It's designed for people who want to try it on Windows. You can go download it. It doesn't infest your system with little pointers to things. It's all self-contained. And that's built on Cygwin. But the distribution that we use for our official Windows builds is based on EDA Tools. So you would get a native version of all of those utilities. I believe EDA has many of them, but the one that we use is kind of an old school one. And, but you could use other scripting engines, but the one that's built in, which is the one you would expect to work, is the M4 preprocessor. And everybody goes, what?
KeyCap uses WX widgets.
Yes, they use WX widgets, so they have a consistent look and feel across all of them. But at the same time, it may not look exactly like the native ones. The Jita suite uses GTK for most applications, but for the layout tools, we actually have the ability to switch to a native tool chain, or the tool set on each one, although we haven't quite gotten there yet. But we do actually have two different GUIs for Linux-based tools. One that's based on GTK and is more user-friendly, and another one based on motif widgets, which is for power users and allocates a far greater percentage of the screen to your layout. Because we all know that we need as much screen real estate as possible. And in fact, one of the projects I'm working on is having dual screen support, where you can have two different views of your board on two different windows. So you can use one of them to pan around heavily. So, and we're constantly working on performance, getting the speed up, et cetera, et cetera, et cetera. But in general, yeah, Windows, Linux, Mac, etc. Any other questions?
Is there any limitation on layers? How many layers you can go for layout?
Limitation on layers, it depends on how much memory you have. I found once you get to about 56, the user interface becomes a little difficult to work with. And as far as board size goes, at the moment we're limited to about a quarter of a mile. Quarter of a mile at 0.01 mil resolution. My house is really, really small, so I sort of board that big. The free software philosophy is that you never put limitations in your code. You try to code in such a way that they can do whatever they want, limited only by their own hardware. The default build starts you off with 8 layers and allows you to add up to 16, or a total of 16 layers. If you need more than that, there's one spot in the source where you change a 16 to however many you need. I know people who use it for 24-layer boards regularly. So if you can picture a 24-layer board a quarter of a mile. We do not currently support blind and buried views. It's next on our list of things to do. Most of the people who use our software so far have not needed them because they can't afford them.
Because you think with some micro VGA, you can use some blind and buried views.
Yes, and it's a very popular request. And we do have some people who have added patches to it to support blind and buried views. We just haven't integrated them in. So you can go and get their patches, add them to our source, and get that functionality in an experimental way at least. Something that you sort of can't do with other packages, although they already support blind and buried views. But yes, that's definitely on our to-do list for the upcoming releases.
You mentioned earlier that there are freeware operating systems now, or operating systems based on the freeware. Are there any cell phones that were developed, for example, on commercial products? I realize your board is...
You mean cell phones? The question is, are there any cell phones that were developed with free software? Do you mean developed with or developed using free software?
Actually, both.
Okay. Do you have an iPhone?
I do not.
Do you have an Android phone?
I do not.
Do you have a Nokia smartphone?
I do not.
Then for you, the answer is no. But the iPhone was developed based on the BSD kernel, which is open source software at least, and they use the GNU toolchain for all of their development. The Android platform actually runs a Linux kernel, and all of their tools were built using the GNU toolchain. Nokia smartphones, many of those are based on a Linux operating system. And the Qtopia phone also was based on a Linux operating system.
That's the personality, but I'm asking about the personality and also the hardware. The entire pack.
I don't know if any of the phones, as far as circuit boards, have been made using free software tools. I do know that there are some very impressive things out there that I can't tell you what they are that were made with free software because the electronics companies tend to be very secretive about how they produce their boards. I do know one company who's willing to talk. They have a testing framework for hard drives. All the hard drives that are manufactured in this area, they have a very high-speed reliability test platform that's based on a number of boards about yay big with, I think, very high-speed FPGAs on them, running custom hardware and custom firmware in order to do super high-speed testing of hard drives, and that was done entirely with free software tools. But the most exciting project that I know about that uses free software tools is a couple of million miles away on its way out of the solar system. There are a number of research projects for deep space telemetry and near space that are built using free software tools.
So why would companies be ashamed of having used it before?
It's not that they're ashamed of it, but even if they use commercial tools, most companies do not want to tell you which tools they have chosen because they feel that that might give some insight on the design processes. And that's usually a closely guarded secret in most electronics companies. I don't know. I like telling people what I use, but whenever I ask people, that's usually the response I get is that they consider that to be a trade secret, their choice of EDA tools. And certainly if I see a lot of boards that are designed with free tools that I can't tell anybody about because the boards themselves are trade secrets. But we help them fix bugs in our software and learn how to use the tools. They give us the copies of their files to help them.
What might help? I don't know, DJ, are there studies that have been done to show any kind of metrics that would show the adoption rates of some of these tools within the engineering community?
I haven't seen any studies yet. I know that we're becoming more and more, we're getting there slowly.
Yeah.
And granted that we're more targeting the lower sized boards, the entry level type things. We consider our competitor to be more Eagle and less Altium Designer because they're huge and they do everything and they're very hard to compete with.
Sure.
But we have started seeing some independent design firms using the tools to do their designs because it lowers their cost of entry and it allows them to do some things that might be easy. Anything else? All right. So, screenshots. We're doing screenshots. So we have some screenshots here of the Gerber viewer, and we can export to PDF just fine. And we have a photorealistic exporter for our layout package, which has thrown a number of people. Oh, you have the boards already? No. in fact, the presentation you should have seen had a big pop-up of the board that I designed, and it looked real except for the gold that was tin because I used that picture and pasted on pictures of all the parts in order to make something that looked like a board. And that started off as an experiment by somebody who had exported the different layers into a paint program and blended them together to get something that looked like a real circuit board. We thought that was really useful, and we integrated it back into the product. And here's some examples of our simulator output. We have both, obviously, analog and digital. And this particular trace you see on the digital one, I had done a project with an FPGA. I used our simulator to simulate my basic design. I did all of the layout with the Xilinx tools, and I took their post-layout design and simulated it again with our simulator, not theirs, because theirs didn't do what I wanted, to see all of the timing issues. Took the code, put it in the FPGA, put a logic analyzer in the FPGA, got the actual data back out, ran it through the same charting software to get the live data. So the one tool did pre-layout, post-layout, and actual data. So let's talk about the development end of things. Hopefully by now you've all heard of the GNU tools in GCC. We've been talking about it a lot with RX. And And this is a whole different category of tools from the board layout tools. These types of tools are the same tools that we use for our native desktop environments. The same enterprise class software that's used by companies like the New York Stock Exchange for their Linux-based servers, we use for our embedded development. The same GCC for iPhone apps can be used for your SH tools and your RHC and even new RX tools. And these can be supported by anybody. Anybody who chooses to offer support for these has the ability to go in and learn about the tools and provide support, either global support or some niche thing. Red Hat certainly makes most of their money selling support for free software. KBit Cummins is very well known with Renesas for supporting the Renesas products. Renesas supports things. There are many others who maintain and support and add to these tools. And performance-wise, well, Renesas just released the core mark numbers for the RX last week, and hopefully you were all impressed by those numbers. I know I certainly was, and I was the one who did the work. We're very comparable, if not surpassing, the proprietary offerings depending upon the various chips and whatnot. Obviously, you have to do your own benchmarks to find out exactly what performance you're going to get using free software. So we found in many cases we surpass proprietary tools. Why? Because we've had decades of experience with engineers from many companies working to make this one platform produce optimal code. An optimization that was done for the Intel architecture might apply to the RX. An optimization done for a Toshiba microprocessor might work with an RHC processor. Having a group that does just tools for one processor can't compete with an entire planet putting together a tool chain for all the processors. And of course we have debugging, either embedded stubs which run in your part, or third-party drivers. Despite the fact that these are free software tools, they can be integrated with proprietary offerings for hardware-specific debug, from JTAG debugs to the RX debugger, et cetera, et cetera, et cetera. And of course, writing software is no use if you can't get it in the chip. And while this isn't free software, this is a hardware thing, I think one of the strong points that Renesas has with their offerings is that the protocol that they use to program their chips is documented. It's an open format, and anybody who wants to add their own value to the programming process can do so. I prefer to use my own solutions for these, but I have some cases where I have one microprocessor, programming microprocessor next to it. And these are things that you can do when the specifications are available, when they're not hidden behind some NDA. And of course, source control is an issue in any development project. You need to be able to save all of your work. And there are a large number of free software offerings for source control which are used worldwide. Most of the free software projects, of course, use their own free software-based source control. And depending upon your needs and the flow that you need, there are different offerings. For example, the Git source control tool is used by the Linux team because they are so diverse and dispersed. And they have built this package which is designed for their needs, which is to accumulate patches and changes and bring them up through a hierarchy of review and acceptance into the final product. So let's focus on the GNU toolchain for a moment. In free software, there are a number of different ways that you interact with the toolchain. In the center of all of this is the Free Software Foundation. They are the owners of the code. The code is all copyright by them. They don't usually do maintenance of the code or working on the code, but they are the guardians of the code. They ensure that the work that is done on the code is done to the appropriate quality, and that from a legal standpoint, the people who are using the code, distributing the code, abide by all of the rules. As for the people who actually work on the code, there's a number of different ways that they interact with the source set. For example, new ports can be added by any third party to the core set of tools. Renesas, when they come out with a new chip, will contract out with a third party supplier. Often it's us at Red Hat. This is what we do for a living. And they will ask to have a port added to the tool chain for a new processor. And we will work with them in the Free Software Foundation to put together a port which is acceptable to both parties and add it to the core port. You can also add new features to the tools. For example, you may want to add cycle accuracy to an existing simulator. You might want to add compatibility with another compiler, to the compiler. You may want to add hardware support to the debugger. These extra features, again, get added into the pool. They work with the software that others have been writing over the years. And they extend the functionality so that everybody benefits from everybody's work. And the third major way of adding is optimizations. I mentioned performance before. There are a lot of companies that do nothing but optimize these tools, mostly for code generation, but also for the user experience. And they all work together to provide one tool chain that they all share. So each group does the part of the work that they're best at. Now, on the other side of this, we have distributions and support packages. And by distributions, I mean more than just a Linux distribution. I mean, if you get a board from Renesas, it will come with a CD with all of the tools on it. Or you might buy a support package from Red Hat that includes tools. These are the distributions that I talk about. And support packages, you might buy an annual support package from Red Hat or cable companies. You might go to a third-party consultant to have them support you in a particular way. You might find somebody who is willing to be on site with you as you bring a new tool up to speed, or bring more new engineers or a new product out if you've got a deadline. These are the kinds of support packages where people can draw from the FSS pool of software in order to provide these services and offerings to customers. But you notice that the users of the software interact with all of these different parts of it. The users can request new ports. They can fund new features and optimizations. They can go directly to the FSF and look for new bug fixes that they might need at 3 o'clock in the morning on a Sunday because they have to ship on Monday and their support contract doesn't cover that kind of thing. Yes, it's happening before. And they use, of course, the distributions and the support packages. So everybody works together. And then lastly, in this chain of development, we've got embedded development is the standard free software IDE. The Eclipse IDE is the standard for free software development because it supports everything. It's highly customizable. You can do everything from Java to embedded to native to all sorts of weird things. You can integrate in third-party applications into it. In this example, it's doing a RAC, my lab, using a piece of custom software that I wrote to download the code into the chip. I integrated that in myself so that I can do my lab. And lastly, on the embedded development. Question?
You hear a lot about companies these days releasing an IDE for their product. And you ask them questions about it, and they say, well, it's based on Eclipse. But it's their proprietary product. They release it, and they say, here, this is from us. This is our IDE. Oh, by the way, it's based on Eclipse.
Right.
Does that work? How are they able to do that? Are they just...
From a legal standpoint or a technical standpoint?
I don't know. I guess maybe both, but are they just doing all the hard lifting to get CDT integrated in?
The question is, how do these third-party vendors provide their proprietary offerings based on the free software IDE codes? And the answer to that is that in the free software world, from a legal and technical standpoint, they define well-known APIs between the core product and the extensions. And these APIs are, of course, published. And normally, they would use these APIs for their own free software extensions to the packages. But because the APIs are well-known and their intention is that you can attach other works to it using these APIs as communications channels, then that allows third parties to have proprietary offerings which use the same APIs, the same communications channels, to extend these free software offerings in a proprietary way. So it makes it easy for you to say, you know, we need an IDE for our product. You take Eclipse, you add your product, ship it out. Granted, you have to follow the rules. You can't change Eclipse to include proprietary code and then ship it. That's against the rules. But you can add a plugin or have it call a proprietary function, in which case the configuration parts, the CDTs and the scripts and the setups, those are part of Eclipse, and those become free software. But the things that they're calling the external programs and applications can remain licensed under whatever terms you wish. And we'll talk about licensing later, because that's something that always takes a lot of time.
This approach, I use this approach in Visual Studio. They have a tool there, and we were configuring animate there, which was calling Hitachi.
Yep.
Compilers, linkers, and all this.
Yep. And HEW does exactly the same thing.
Yeah.
You integrate your tools into theirs using a well-known API.
Usually, editor in Microsoft was at that time much better than.
Well, for those of you taking my lab later, you'll get a chance to try this and see if you like this editor better. Anyway, so I mentioned the serial programming before. I think this is one of the strong points of Renesas, that they document the protocol that the chips use. Not the protocol further out on the other side of their proprietary offerings, but the core level protocol. So if you wanted to add your own way of talking to these chips, you have the ability to do so. Well, it's not free software, it's an open, it's the free software philosophy that they're following in this. So any more questions on that before we get on to the next section? Excellent. And mostly on time. So, the philosophy behind free software. Now, philosophy is kind of a touchy subject. A lot of people talk about free software. Not all of them understand what it is. It is not a religion. You do not have to go to the poorhouse because you have to give everything away. It's a set of core beliefs that can be leveraged to add value anywhere in your business plan, from internal operations to customer experience. Some of them are practical. Some of them are less tangible, like dealing with community, marketing. Calvin was all about this. And I'm going to break down into these 5 key points that I'll cover about the free software philosophy. Sharing. Now, when I was a kid, my mom told me to share my toys. Didn't want to. She thought it was a good idea. Sharing is how you grow a community. Each one who knows helps the ones who don't. We want to grow our communities. Certainly, from a business standpoint, you want to grow your customer community, your partners, your suppliers. Because the more people using your product, the more opportunity you have for profit. We all want a profit. Hopefully. And in software, it used to be that way long ago. You buy a piece of hardware, they would give you the software because that was the only way you could use the hardware. Until some companies realized that they could create an artificial scarcity in software, start charging money for the software itself. And that worked for a while, but these days it's changing. With the advent of the internet and the web, it's become trivial to share and copy software. The individual ones and zeros no longer have any intrinsic value. People can work together to add to the project, to provide feedback, to be part of the testing cycle, so that instead of releasing your final release and then finding out that everything's broken because you didn't test it the same way you're using it, your users can get involved earlier and help you avoid the diminishing returns of testing. On the other hand, each participant must share responsibility and control for the project. And this is where a lot of people have problems with free software, because they want to own the software. They want to be in charge. They want to be the top dog. In free software, the mindset is that you work with other people to add to the software package. You don't own it. You work together. On the other hand, the people who use the software are expected to help with it. They want you to give back a little bit. If you go and download a piece of software and you've got a way that it can be a little bit better, you're expected to provide that feedback to the original project so that you can help grow this package that you got for free. Community. The community aspect is another intangible to this thing. It's hard to justify this. There's no direct revenue stream involved in community. But a lot of companies are growing their community. Renesas certainly is putting a lot of effort into growing their community with Renesas University, Renesas Rules, and all of their other community programs. The pervasiveness of the World Wide Web has certainly made this easy. And it's become expected of companies to have an online presence where they interact with their community and they share ideas and their community members will help each other. You can make a business case for this, where your customers become more loyal to you and more likely to choose your product because they can talk to other people who are using them. On the other hand, your growing pains are public. If you make a mistake, you have to be willing to say, I'm sorry, and move on. The more you involve your community early on, the more they're going to see the problems early on. They can help you with it. You need to let them help you grow your products. You have to involve them. The free software motto is release early and release often. We might have 4 or 5 alphas and then a whole series of betas before you finally get the one release that's the final release. And most other companies would be the only release. And then we follow it on with bug fix releases, many of them. Why? Because we want to get the right stuff out of their customers as soon as possible so that they can help us provide feedback. We want to turn around. We want really fast turnaround times. And the free software philosophy encourages fast turnaround times. Now, support is where the revenue usually becomes more tangible. Red Hat certainly focuses primarily on support and makes most of their money from support packages. We do not sell software. We give the software out as part of a support package. The support aspects of free software, I don't just mean fixing bugs. This is where you profit. How do you profit from free software? Well, volume, for starters. I first joined Red Hat as part of Cygnus, one of the Red Hat acquisitions, and our motto was, we sell free software. Where do we make our money? Volume. But seriously, we make money with support packages. How do you do that? Well, if you know more about your product, then people will pay you to teach them about your product. But support means more than that. There's other groups working with you to provide training and to provide packaging. KP Comments, for example, there's a lot of effort into packaging the GNU tools such that the customers get a good user experience with it. Also, there doesn't need to be a central offer for any given package. There certainly isn't a central authority in GNU tools. That responsibility is shared. People who contribute a specific feature are the people that you can go to ask questions about it. And public forums and business-to-business opportunities have become the standard way of dealing with these support issues. Going online and saying, hey, you wrote this got a bug. How do you fix it? Or even better, hey, you wrote this, there's a bug. I've fixed it. And the thing you need to understand is that the value in your product becomes the support. The ones and zeros do not have intrinsic value anymore. They're just data. They're, I won't say worthless, but it's so trivial to copy them that there's no hard value in them like there would be in a hardware product. So you focus on your core competencies. The intellectual property that you have now is your intellect. The people that work for you, your history, your relationships with other customers. It's that type of information that you have that is valuable, your people skills. And your customers and other people will pay you to be there for them when they need you. Provide training materials, to go on site, to teach them, to fix bugs, to answer the phone at 3 o'clock in the morning because they have a release the next morning. I've been there. As part of the preparation for Devcon, I pulled many all-nighters waiting up in case Renesas had problems with their pilot tools. And we would respond within hours because that's what they needed and we knew how to do it. And they needed that level of support and we provided it. And the other key part is to understand that all of these other parties who are providing support for your product as well are not competitors. They are complementing your offerings. People look at Red Hat versus Kika coming and they say, aren't you people competitors? No, we're not competitors. We're both working together to provide some different levels of support to customers for the same core software. Now, license and licensing are two different things. The license refers to the software. Licensing refers to your business practices, and I'll cover those separately, unless somebody wants to ask questions about what I've already covered so far. Now, the software license gives freedoms to others, but it also prevents users from denying those freedoms to others. So if you give your customers a piece of software, they can do what they want with it. If they pass it along to the next person, does what they want with it. The software never becomes less free. I like to call this freedom for the software, not freedom for the users. The users can't do anything they want because they can't restrict others. The software is the part that remains as free as it's ever been. And of course, there's no worries about unauthorized copying. How do you pirate something that you're legally entitled to give to other people? It's like, I've got an illegal copy of this. No. If you have a copy, it's a legal copy. Granted, there may be issues with illegal distribution of free software. If you distribute a binary and don't offer the sources, then legally you have lost your ability to distribute the software. But the people who have your software still have all the rights that they started with. Of course, they have to fight in court to get the sources from it. But the whole issue with piracy just doesn't exist. Community-driven extensions and enhancements are allowed, if not encouraged by the license. They want you to do more with the product, to extend it, to add your value to it, to do innovative new things with this package that the original authors may not have intended or expected or even thought possible. Security by obscurity is no longer an option. The license requires that your user be able to look at your algorithms and see if they're secure enough for their purposes. If you thought you could get away with shipping that little piece of security software that almost works but not quite, you have to get it out anyway, hopefully nobody will see it. Think again. You now have to be secure by really good design. And this is the hard part for people to wrap their heads around it. There's no such thing as software intellectual property. Granted, there is software IP from a legal standpoint, and many companies do have this. From a free software point of view, the intellectual property is not the ones and zeros. There's no intrinsic value in something that can be copied for no cost. The intrinsic value is in the things that can't be copied. The people, the experience, the history, the relationships. And the licensing, the flip side of this, since the license is different, the licensing practices are different. And from a business standpoint, it simplifies your business model. There are no activation fees. There's no per-seat fees. You don't have to worry about how many people are going to be using the software when you go to a company. The real issue is how many questions are you going to ask? You need to be able to ask these questions outside of normal business hours. Are you having a lot of trouble? Do you need somebody on site? The interactions are where you worry about headcounts and things like that. But you don't have to worry about them making another copy on another PC. That whole policing thing goes away. There's no licensing dongles you have to worry about. There's no no-block PCs. You won't have some customer who had their Ethernet card broke and they had to put a new one in and suddenly their CAD software isn't working anymore the day before release. That's happened to me before. How many people have had their software suddenly stop working because of licensing issues? Yeah, I see a lot of hands going up. Free software doesn't happen. On the other hand, licensing is no longer a revenue stream. You can't charge for the software because it's the right to copy. You have to put the value in the people behind the software. The value is in the support packages, the packaging, the community that goes with it, and all of those other things. On the other hand, because you can offer different levels of support, you can attract smaller customers. A customer producing a $40 device is not going to be able to pay $10,000 for an EDA package, or for for a full support package. Maybe they just need the free software and they need a week's worth of 3 questions, and they buy the small support package. And finally, it allows for an unlimited try before you buy. How many people have written something using an evaluation copy of the software, only to find out 30 days later, just before the release, that it doesn't work anymore? Yeah, a lot of hands go up. With free software, you can give them the full version up front. If they like it, they just keep using it. If they have problems with it, they buy support packages. And there are many online resources for you which are part of the presentation. And certainly the web will find you many resources to further extend your experience with free software. Any questions on the free software philosophy? This is usually where I get the licensing questions.
Can you clarify on the GPL versus LGPL?
The LGPL, also known as the Lesser General Public License, is designed for libraries and packages that have other alternatives that aren't free. And it allows you to replace a proprietary package with an equivalent free package without having to open up your whole application. If you use an LGPL library, the part of your project that has to be released as source is just that library, not the whole rest of it. You still have to provide a means for your customers to link a modified version of the library in with the rest of your offering. But you don't have to provide the sources to your rest of your offering. Providing a large object module is sufficient. They use that as a means to get free software to places where a proprietary offering already exists and they're simply trying to replace it, and there's no real value in the new software. The GPL is used in cases where the software is not replacing it, but it is better than some other offering. For example, GCC is GPL because it has so much more that they feel that the extra pieces of the software are sufficient to warrant the GPL.
And the Google platform, uses the Linux Bluetooth stack, BlueZ, which is GPL, not GPL, but Google got around with it using the dbus. Can you comment on that?
When you have a well-known API that talks between modules, and I mentioned this when I talked about Eclipse, the API provides a way of separating, from a legal standpoint, one work from another work.
From one domain to another domain.
Right. So the legal scope is the scope of a work. If you have 2 pieces that you've combined together to produce one work, and maybe they're inseparable, they won't work without each other, legally they are one final product. If you have 2 pieces that could work together but don't have to, there's talking like if you use a web browser to talk to a website, your web browser and the web server are not one piece of software. They're 2 things that talk. So by using dbus, they have taken a well-known API to have 2 independent works communicating with each other. So they have independent licenses. Anything else? Wow, I usually get like an hour's worth of questions on illegal issues.
Are there any mechanical design packages
Yes.
being worked on? You don't know that often.
There are some. Mechanical CAD is one of those interesting fields where there's so many special things you have to do that it's very difficult to compete with proprietary, but there are some. There's probably many varying levels of
More of a comment than a question, but I think one of my favorite free software packages is the WAMP suite.
Oh,
Maybe you didn't mention it, but it's just,
I did.
Our business is Bugzilla.
Oh, yes.
From Mozilla. I manage so many different groups using Bugzilla. It's probably the best. It's arguably the best bug database out there. And it's free. And it's very customizable. It's a lot of cool.
My favorite free software at the moment is Quake 3. They eventually released it under the free software license.
Well, yeah. It's not part of our business.
All right. That's all the time we have. I'm sorry. I'll be available after this for further questions. Thank you for attending.
Another quick question. I'm using Patch right now.